Okay, so sorry, getting a little late start here. So I did put your other drill up for tomorrow, and you could be working on the first homework assignment. After today's stuff, you should be able to do a fair bit of it. Not all of it unless you read ahead, but a good chunk of it. So any questions before we move on? Okay, so we've been talking about data types and defining variables and the difference between an int and a double and a string. So let's continue in that vein and say a little bit more about variables and converting from one to the other. First, we have some shorthand notation, and so you'll see this used sometimes. If I want to do something like x equals x plus y, then you can write it just like that in your program. Or there's a shortcut. The shortcut is you could write x plus equals y. And these two things do the exact same thing. So why would you want to do it this way? Well, it saves you from having to retype the variable a second time. In this case, it doesn't save you a whole lot of typing, but if you had some long variable name like num of employees or something, instead of num of employees equals num of employees plus 10 or whatever, then you can just write this instead as num of employees plus equals 10. So that's just a little shortcut notation. You can do this with more than plus, so you can substitute any arithmetic operator in there. And so if I do x minus equals y, let's do it this way. X equals x minus y is the same as x minus equals y. Or I could say x equals x times y, and this would be the same as x star equals y. And divided by you could do as well. And you could even do modulus. So if you see that, then you can use the shortcut. Yeah?
Do you always want to make sure there's spaces for the characters?
In this case, normally there's no space between like the plus and the equals, but usually you would put a space like after the x and before the y, and you don't have to put one there. And so Java will actually skip over extra spaces and tabs and things. But just to make it kind of readable for people, it's a good idea to put a space there. So I'd recommend you separate them by spaces, but you don't have to if you didn't want to. Okay, so that's the shortcut operators. We already mentioned the precedence rules. So let's say a little bit about converting types. And so it's pretty common that you'll have something that's a double or a float, and you want to store it into an integer, or vice versa. To do that, we have a thing that's called type coercion. And basically that's telling Java, let's treat something like it's a different data type than what it naturally is. So an example of this would be something like we have a variable that's a double. I'll just call it D. Let's call it set 3.9. So I have some variable that's set to 3.9, and I have some other variable that's an integer, and I'll just call it X. And if I do something like x equals d, then Java will complain because on the right-hand side, I have something that's a double, but on the left-hand side, I have something that's an int. And so Java doesn't know, well, it could do something, but it complains because it's worried you're converting a double to an int, and you can't store the stuff after the decimal point in the int. So possibly you're definitely going to lose some information, and possibly it could make your program not work correctly. So if you try to compile a program like this, Java will give you error messages. But you might know better, and you might say, I know this is a double on the right-hand side, and it's an int on the left, and I just want you to copy the double into the int anyway. And so to do that, you do the type coercion, where you put inside parentheses what data type you want it to be, and then the value to the right, like D. And so now this tells Java, take this thing that's a double, or whatever it is, D, treat it like an integer, and then copy it into X. And the rule that Java uses is if you have a floating point type on the right and you're turning it into an integer type, then it chops off anything after the decimal point. So the result in this case is X would get the value 3. So it wouldn't round up or anything, it just chops off whatever is after the decimal point. If you did want to round, there actually is a way to do it. There's a function called math.round. It would look like this. You would write x equals math.round and then give it d in parentheses or whatever number you want to round. And this would take this number and round it up or down. And in this case, x would get the value 4. So here we're typecasting to an int, but you can typecast to other things as well. So I could typecast to a long. So if I had 3.587, I wanted to treat it like a long, then I just stick a long inside there instead. And you can go the other way around if you wanted to. And so I could have like float f equals float x. So x is already an integer set to whatever it is. And if you want to copy that into a float, then you could typecast it. Now, normally you don't need to typecast this direction because going from an integer type to a floating type, you can normally do exactly because the floating types can represent integers as well as floating point numbers. Where you could run into trouble is some of the numbers they can't represent as well if they're really large. So like if a really big integer, you can't represent that as a floating point number exactly. So just be aware there are some limitations. If you have really big numbers that are integer types, they might not translate into the floating point type. If I made this double, then I should have no problem. The basic reason for this, the way that the floating point types work is they're basically storing the number in scientific notation. So it's like, 3.587 times 10 to the first power. So it's really storing the number in scientific notation, and it's only got like a fixed number of digits it can store over here. So let's say it could only store 5 digits. 1, 2, 3, 4. So if it could only store 5 digits here, then if you had some number that was like 3587772, then it couldn't store this all the way to the 2 because there's not enough space to store it. So it would only be able to store 35877 times 10 to the first power. So this would actually be approximated as 358770 if it's trying to store it in the floating point format. So anyways, you don't really need to worry about that. But that's the reason why you can't exactly store all the integers as floating point types is there's just not enough space to store the digits. Okay, so this is, you can only do this typecast thing for numeric types. You can do it for other types we'll see later on, but it doesn't work for strings. So don't typecast strings. So sometimes you'll have something like a string, and maybe the string contains actual digits in it. So we've been using things like, words in here like hello, but what if the string contained digits like 1, 2? Well, the problem is, if we ever wanted to do math operations on this, then we can't, because this is stored using a format where it's like the code for 1 and the code for 2. It's not stored as like the number 12. So if you actually want to do math operations on this, then we have to do some conversion to turn it from a string into an integer. So anyway, we'll talk about how to do that later, but you can't do this. You can't say x equals int s. That doesn't work. So if x is an int, you can't just put an int in front of a string and expect it to turn that string into an int. There's a function we have to call to convert it. Okay, so let's have a couple little examples. If I have int x and say x equals 11 divided by 2, then what do we get next? Anybody? You get 5, right? So this would be 5.5, but since these are integers here, it's going to throw away after the decimal point, and you just get 5. And so what you might think is, well, all right, I'm going to fix this. I'm going to make it so instead of an int, I'll make this a double. And so you might think that by making x a double, x can now store 5.5, but if we ran this, you'd still get 5. And the reason is, when Java sees the 11 and the 2, it does integer division over here and then gives you just the 5. And so if you want to get the 5.5, one of these two things has to be a floating point type. So we have a couple ways to do it. One way to do it is you could do the typecast for any one of these. So I could maybe typecast the denominator to a double. So if you turn one of these into a float or a double, then the whole thing will be calculated using floating point division. Then x would get 5.5. Another way you could do it, so I could do it with the 2 or I could do it with the 11. So as long as one of the values is a float, the whole thing gets done as a float. Another way I could do this is if I had these specific values, I could make one of them being a floating point type by putting a 0.0 after it. And so if I put a decimal point in here, then this is now represented as a floating point number, not as an integer. And specifically, this is treated as a double. So a double is the default type whenever you have a floating point value just sitting there in your program. Let's see. So we saw this problem the other day. If we have x equals 2 divided by 4 times 4 divided by 2, then we said according to the precedence rules, we would start from left to right. And so we do this division first. We do 2 divided by 4, which is 0.5. These are integers, so you just get 0. So then you get 0 times 4 to give you 0, 0 divided by 2 to give you 0. So one way we could fix this would be take one of these, like make this a 2.0 instead of just a 2. And so now Java would do floating point division, and you get 0.5 times 4, and so then that would give you 2, and then you get 2 divided by 2, and then we would get 1.0 as a result. Okay, so let's do an example where we actually get to compute some stuff. So our example is the Twix calculator. In case you've ever wondered, if all you ate were just Twix bars and you never moved, like you just sat in bed and just ate Twix bars, then how many would you have to eat so you could stay alive and have your weight stay the same? At least stay alive until you get diabetes or something. So as far as maintaining your weight, how many Twix bars do you have to eat? So we can use a formula that is the Mifflin-St. Jeor equations, and it's an approximation based on physical activity. And I'm not sure why, but for some reason, females require, according to the formula, require fewer calories than males. But whatever, I don't know a reason behind that. But here's the formula. For a male, if you weigh k kilograms and your height is h in centimeters, then take your kilograms, multiply by 10, multiply your height in centimeters by 6.25, add them together, subtract off 5 times your age in years, and then add 5. And then that's an estimate of the number of calories you would need to stay alive. Or not just stay alive, but to maintain your weight and stay alive. And then here's the formula for females, which is the same except it's minus instead of plus 5. So this gives you the number of calories that you need, and so it's calories with the capital C, like a kilocalorie, as opposed to a little small c calorie. But that'd be the calories you see on food labels. So if we compute this, then it would tell us how many calories we need to maintain our weight, and then we can go to our favorite food group, like Twix, for example, and one package of Twix has 568 calories. That's 2 bars, not 1 bar. And so if we take the total number of calories you need, divide by 568, then that tells you the number of Twix packages you need to eat to maintain your weight. So let's make a program that calculates the number of Twix packages for us. So what we need is the age in years. So let's start with the age in years. And then here in the United States, we don't normally think of how tall we are in centimeters, but we think how tall we are in feet and inches. And so let's input our height, or we're not inputting yet. We'll code in the program our height in terms of feet. So like I would be 5 feet, and then another variable for inches. So I'd be like 5 feet and 5 inches. So I'd have 2 variables, both set to 5. And then one more variable, which is our weight in pounds. Okay, so if we input these things, then what we need to do is translate pounds to kilograms, because the formula is based on kilograms. So we need to, So we have to translate pounds to kilograms. And the other thing we need to do is translate feet and inches to centimeters. Once we do that, then we can plug them into our formula. In this case, I'll just do it for males, but you could do it separately for females. And then divide by 568. So so we might think about, before we start writing our program, we could think about how we're going to solve it. And one thing you might think about is what variables you might need. And so here I've already given 4 variables that we need. So we need a variable for the age in years. And so that would probably make sense to make an int. So we have an int for age. Weight in pounds, most people wouldn't say they're 120.3 pounds, so most people just round to the nearest pound. So that would be something we could also make as an integer. And then height in feet and inches, same thing. Those would also probably be integers, or whatever, 6 feet and 1 inch tall. So we have another variable for height in feet and another one for height in inches. So these are basically the inputs for the problem. And then all we'll do for our problem is we'll just set them to values in the code. So we'll just hard code them. We'll say age equals whatever, 30, pounds equals however many pounds, 110, etc. So we'll just stick the variables right there into the program for whatever person we're interested in calculating this for. Okay, so here we need to figure out kilograms, height, and age. Well, we already have age, that's just whatever we input, but we need to figure out kilograms and height in centimeters. So it would make sense to have another variable for kilograms, and we'll leave off the data type for now, but we'll get back to it in a second. So we'll have some variable for kilograms, and if you go look up in your metric conversion tables, you would find that kilograms, you would find that 1 kilogram equals 2.2 pounds at sea level. So we could pretty easily convert to kilograms by taking the pounds and dividing by 2.2. So here let's write a little bit of sort of pseudocode for this. So we would start out by setting the age, pounds, feet, and inches to desired values. And then we compute kilograms. And the conversion is kilograms is equal to pounds divided by 2.2. So whatever our value is for pounds, we divide by 2.2. So if we're dividing by 2.2, then this gives us a hint about what would be a good data type for kilograms. So over here on the right-hand side, I've got a floating point double for 2.2. So it would make sense to make kilograms be the same kind of data type. So let's make kilograms be a double. You could make it an int if you wanted to. If you made it an int, then you'd have to, when you do the code, you'd have to do like some typecasting. So the idea would be here we compute pounds divided by 2.2 as a double value, and then turn that into an integer, and then store that in kilograms. So obviously if you did it this way, then you wouldn't have fractions of a kilogram, you'd just have, integer kilograms. Okay, so we get the kilograms, and then we also need to figure out the height in centimeters. So we look around our conversions, we might find that there are 2.54 centimeters per inch. So one strategy we might do is we might calculate the total number of inches in terms of height, and then multiply that by 2.54, and then that should give us how many centimeters tall the person is. So to do that, we would compute height in centimeters would be 2.54 times the total number of inches. And then to calculate the total number of inches, we would take the feet, multiply that by 12, since there's 12 inches per foot, and then add in the extra inches. So that would be 2.54 times feet times 12 plus inches. So here we take however many feet tall we are, figure out how many inches that would be, add in the extra inches tall we are. That whole thing becomes multiplied by 2.54, gives us the height in centimeters. And then the last part we'd need is we can use the formula up here to calculate the number of calories. So then I have calories equals the stuff in the formula, 10 times the age plus, what was it, age? Or kilograms. Plus, etc. So if we do this computation over here, let me go back to the formula. If this is our formula, then what data type should we make for the calories variable? So the one that would probably make the most sense would be make calories be a double, would be maybe be the easiest, because you have doubles over here, like the 6.25. But if you didn't really care about fractions of a calorie, then you could make an int, but then you'd have to typecast the whole thing to be an integer. So here I'll just say let's make calories be a double. And then the last part is we'd calculate how many Twix packages to eat. And so the Twix packages would be the calories divided by the number of calories per package, which I said was 568. In this case, we probably do want Twix to be a double or a float. And The reason for that is you probably do want to know what fraction of a package to eat, rather than round down to the nearest Twix package. Or if you even just truncated it, then you wouldn't be eating enough Twix to survive, so that could be bad. All right, so that's the strategy. So this stuff over here is an example of writing pseudocode where it's not really code, it's sort of like code, but it's got some English stuff thrown in there. So now let's translate that to actual working code. And I got my Dr. Java to work. Apparently it doesn't work with the newest version of Java. Like there's a Java 8 out, and it doesn't work with it yet. But all these computers are using Java 7 something, so it's not a problem. But as far as this class is concerned, we're not really doing anything that's Java 8 specific, so it doesn't really matter what version you're using. All right, so here is Dr. Java, and let me go. I'm going to just start with this program I've been working on so far. Let's just delete this. Okay, so here I'm just starting with basically a blank program. And here we wanted variables for the age. And I'm just going to set it to some random value here. Weight, 210 pounds. Feet equals, how about 5 feet and 9 inches. So here we have, only do this for males. So here I have a 60-year-old male that's 210 pounds, 5 feet and 9 inches. So the rest of the calculations are, the first thing we had was to compute the kilograms as pounds divided by 2.2. So I'll make a variable double for kilograms. I'll just call it kg. So kilograms is just pounds. Oops, I didn't put pounds. Oh, I put weight. I'm going to rename that to pounds. So a kilogram is pounds divided by 2.2. And then we had centimeters. We can do this a couple ways. You could say define the variable up here, or you could just define the variable right where you use it. So I could say double centimeters, and we said centimeters was 2.54 multiplied by feet times 12 plus inches. So there's the weight and the centimeters, and so now we're ready to calculate the number of calories. And so I'll do it this way. Calories equals, we use the formula 10 times the kilograms, and maybe I'll go ahead and put parentheses in here. 10 times the kilograms plus 6.25 times height in centimeters plus, minus 5 multiplied by the age plus 5. So I didn't need to put parentheses here because the precedence would do multiplication before addition and subtraction anyway. But sometimes it's nice to put the parentheses there just to make it clear what order things are happening in. Okay, so there was the number of calories, and so now we calculate the number of Twix packages. And that's simply the number of calories divided by 568. And so now we can output to the screen. You need to eat num Twix packages per day. Okay, so any questions so far? Yeah.
Double centimeters, is that a 0 or a 2? A 0.84 or
That's a 2.54. Yeah. Yeah, it looks a little funky here.
Say for integer pounds at the top.
That's 210. Yeah, I wonder if I can change my font. Monospaced. Yeah. Yeah, a little bit. It does look kind of funky. What if we don't use monospace? We go to whatever. I don't know. Make it better the other way?
Actually, that is better.
It's a little better.
But the words, or I mean the numbers.
The numbers, yeah. Actually, here, one more thing. I'll just make it bigger. Okay, so there's our program, and then we go to run it. Let's see, compile. And run. And so there's our answer down here at the bottom. You need to eat 3.08 whatever Twix packages per day. So not bad. That's 6 Twix bars. That's for a 210-pound person though. So if it's a lighter person, then it's just a mere 2.2 packages. So don't eat too many Twix bar packages or you're going to gain weight. All right, so one extra little thing on this is sometimes it makes sense to make things be constants. And so for a constant, that would be some value that doesn't change, but you might use it over again. So a typical example would be like pi. So rather than have like 3.14159 like sitting there in your program all over the place, the idea is you can make a constant called pi, and then you reference the constant. In our case, we have sort of two constants here, one for this 2.2 conversion and the 2.54. And so if you want to use the constants, then I'd stick them like up here in between the public class and before the public static void main, and I do public static final. And then in this case, the name of the data type, and then the name, kg to pound. And so here I'm defining a constant called kg to pounds as 2.2, and it's going to be a double. And then the static means it doesn't change, and then the final means you can't change it, and the static means there's only one of it. So then the idea is then I would use this down here instead of 2.2. I'd use my named constant instead. And the program's going to behave exactly the same. And the benefit of this is if there's ever some other place where I needed to convert from kilograms, oops, I did it the wrong way. It should be called pounds to kilograms. Anyways, if there's ever a place where you needed to convert again, then you have a nice name that you can reference instead of some mysterious number. And it might be a good idea for me to do another one for this. And maybe even if the calories didn't change, I might even make this a constant. But if this was going to change, then don't make it a constant. So by defining this thing as public static final, if I ever try to change that, if I ever try to say kg to pounds equals 5, then when I try to compile, it doesn't let me because it's a constant. In this case, I made my name all uppercase letters, And you don't have to, but that's one of the programming conventions, is normally constants are all in uppercase letters. Let's see.
Is that for compiler recognition, or is that just?
No, it's just for human recognition,
Oh, okay.
so the compiler doesn't care at all. Okay. So let me switch gears a little bit here and go on to the next PDF file. So what I have you doing for the drill tomorrow is to basically take this program, but instead of having these things all hard-coded, ask you to input them from the keyboard. So right now it's a little bit of a pain. If I were to want to rerun this, I have to go, put in the new numbers and then recompile it. But if you're ever going to give this to someone else to run, then obviously they're not going to be messing with the code. So the next thing is, well, how can you have the program input values from the keyboard and then run with whatever you just typed in? So that's our next topic, is getting keyboard input. And then I have a little bit about formatting output. So for example, in this program, when it outputs, you get all these things after the decimal point, and maybe you only want it to say 2.3 or something instead of this crazy thing. So there's a way to do that too. All right, so first to get input from the keyboard, there's a class called the scanner class. And if you recall, a class is, well, what we just wrote is a class. Everything is organized in classes. So, here is our Java program class. So this whole thing is the Java program class. So other people have written classes that do useful things, and one of them is called the scanner. And the scanner is able to parse input. So it's able to process like a bunch of text and then make sense of the text. So if I typed in a bunch of letters, 1, 2, 3, hello, then it's able to parse this and figure out that, oh, the 1, 2, 3 is a number, and then hello is a bunch of characters I could store as a string. Okay. All right, go away. So what we'll do is connect the scanner class to whatever is being typed from the keyboard, and then we can process what's typed in and treat them like numbers or strings or characters or whatever. So actually, maybe this is easiest to show just in a program. So let's go to this program. I'm going to delete the whole thing. So the very first thing, if I want to use the scanner class, I have to tell Java that I want to use it. And so at the very top, I have to add import, and then the name of the class. In this case, it's java.util.scanner. And the scanner starts with an uppercase S, so don't forget that. It's very easy to forget the uppercase S. If you do, make it lowercase, you get this can't find symbol error. So it has to be uppercase. Once we've added it, then we have a new data type called scanner. So just like you'd make something like int x, now we have a new thing called scanner, and it's with an uppercase S. This is called an object, and you can tell the difference between objects and built-in data types like ints, because the object types start with an uppercase letter, but the simple ones like ints and floats and doubles start with a lowercase letter. So that actually tells you something when you see string. with an uppercase S. String is actually one of these object types. It's not one of the simple types. Okay, so there's a new type called scanner, and then you can pick a name for the variable just like you'd pick any other name for a variable, but I'll use the name keyboard because we're going to use it to get input from the keyboard. And once you do this, then you set it equal to a new scanner, and in parentheses give it system.in, semicolon. So what is this saying? This is saying make a new scanner object and connect it to data from the keyboard. And the stuff from the keyboard is what the system.in refers to. So it turns out we won't get to it in this class, I don't think, but you could connect the scanner to other things, like you could connect it to a web page. So then like you could be reading in data from a web page and then doing stuff with it, or you can also connect it to like a USB drive and then read stuff from the drive. So the kind of neat thing is the scanner can be connected to all sorts of things, anything that sends in streams of data. So let's say we want to read an integer from the keyboard. I'll just do a system.println, enter an integer. Well, I already have an integer right here, and so to use the scanner, I set my integer equal to keyboard dot next int. So that's the word next, and then that's an uppercase I, so it's next int, all one word squished together. So what this does is when it gets to this line, it's going to sit there and wait for me to type something in from the keyboard. Whatever I type in, Java is going to try to treat it like an integer. And so if it really is an integer, then it's going to turn that into one and then store it in X. But if what I type in really can't be turned into an integer, then you might get some strange results. So for now, let's just print it out. So we'll just say you typed in whatever they typed in. So compile, I run it, it says welcome down here. It wants me to enter an integer, and so then I type in an integer like 83, hit enter, and then it comes back and says you typed in 83. So it read in whatever I typed, stored it in that variable X. What if I run it again, but I don't type in an integer? I type in foobar. Then here it crashes on me because it's not able to turn that into an integer. It is good about skipping over white space. So if I enter like space, 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 tab, tab, space, space, enter, 45, space, 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 tab, enter, then it skips all that white space and then gives me just the 45. And then if I run it and give it like 45x, then here I have a problem because once again it doesn't know how to take that x and turn it into an integer. If I do this, I give it something that's not an integer like 12.3, then it also crashes. So it's a little picky about, you have to actually type in an integer when you're trying to read it out as an integer. Okay, so that's the integer. If you wanted to make a double and read it in, then it's very similar. You set the variable, in this case that's a double, equal to keyboard.next double. So instead of next int, it becomes next double. So whatever I type in is going to be processed as a double and stored in that variable D. So then we'll just print it out. So 6, enter a double, 3.56, and there it outputs it back out. When I do these next ints and next doubles, I'm just going to skip over all the trailing and leading white space, just like I showed before. So if I do a bunch of spaces and 5 and a bunch of spaces, then now it just reads in at 5, and I could do more spaces and tabs. And so all of that leading and trailing white space is ignored whenever you do the next, whenever you do these next, like next int or next double. And then there's another one, but I won't do an example of it, but I could do keyboard.next float instead if I wanted to get a float. But for the most part, you're going to be reading in integers and doubles. And then the other one you'll read in are strings. Do I have it here? So I could have, so to read in a string, I'll make a string variable s. And you would probably think it's going to be next string, but it's not. Instead, it's just next with nothing else. So here we enter a string. So let's see how this works. Whoops, I messed up somewhere. Print line. Do I have another one? System.out.print. Oh, print. So here it read in my string and printed it back out. So here's where it gets a little bit tricky. What if my string I want is hello there, how are you? It comes back and only prints out you entered hello. So any ideas on what happened there? So what it did is the same thing it did for the others. So like with the 5, with this first integer, it reads in a bunch of characters that are digits until it got to a piece of white space and then basically stopped and then tried to process what it had read in as an integer. And then for the next one, for the double, it read in the number I typed in 5 until I got to some white space and stopped. In this case, it's a carriage return is when it stops. And then the same thing happens here. When I type in hello there, how are you? It only reads in a string up until the next piece of white space, which is the space right there after hello. And so with the keyboard.next, this will only read in like connected characters with no intervening white space. So just to show that in action here, I could do this again. So here I'm doing 2 nexts, and so let's see what happens. Compile, run, 5. Hello there, how are you? So then we get the hello and the there because it's reading in the next piece of text there until it got to the next piece of white space. So if you wanted to read in like a whole sentence until you get to the end, you could repeatedly read nexts, but there's another way to do it. I have a thing called next line, and here actually I'm going to go and put it first. So here's a technique that's pretty common, is we use / to add comments, like comments how this program works, what your name is, etc. And so that's a pretty common use of comments. Another way that comments are used is if you have some code in here that you don't want to delete, but you don't want it to run either, then you can comment it out. And so I put a /* in front here, and then I can put a // right there. And so now all this stuff is going to be treated like a comment, and it's not going to be executed or compiled. But if I ever want it back, then I can just get rid of the comments or copy it out or whatever. So that's a pretty common technique to use when you're kind of modifying a program. So what if we do this? Instead of keyboard.next, I use keyboard.next line. And so next line, like it sounds, reads the entire line until it gets to the end, and then that gets copied in. So I run this, hello there, how are you? And so now it comes back and says, you entered, hello there, how are you? Okay, so it looks like we could easily read in integers, doubles, single strings, or a string that's an entire line. Unfortunately, there is a little complication here. And the complication here, I'll show it to you. What if I do this? So what if I re-enable this code right here? So it asks me for an integer first, and then afterwards it asks me for the string. So I compile, whoops, I messed up. I have an extra n comment here. So I enter 6 and enter, and you might note it didn't even give me a chance to type in a string. It just came straight back and says you entered blank. So what's going on here is when we have a next int, and what I think I'll do is I'll go into this in more detail tomorrow, but when you have a next int, and let's say I typed in 10 and then a new line, and then I typed in hello there, when it makes the call x equals keyboard.next int, it'll come over here and see the 1 and then see the 0, and then it gets to this new line where I hit the carriage return. And at that point, the next int stops and says, okay, I just got to a white space character, so I don't need to read anymore. And then it takes the 10 I typed in, and then turns that into an integer, and so the x is set to the number 10. But the problem is, the next character that's going to be read in is this new line. And so when we did the next int, you can think of it as like we're left on this character as the next one to read. And so now when we say string equals keyboard.next line, next line reads until it gets to a new line, but it just so happens that we're sitting right on top of one already. And so this immediately just comes back with empty, with nothing. It does advance this to the next h, but then this string gets set to an empty string because it read in the new line right here. So we'll talk about a way to get around that later, but for now, I just want you to be aware of this, that if you're ever going to mix together like a next int with a next line, then we're going to have to do this special thing in between so that we don't have this problem where you just get a blank string. So that's a pretty common error that people make, and even like well-seasoned programmers forget about this, and this error pops up fairly often. Okay, so let me just real briefly say a tiny bit about formatted output, and I don't want to say much about it because you probably don't have to use it for the class, but you could look into it more if you're interested. And so we have this thing called print. So we can use print line to print out a line and use the plus to stick on variables and stuff. One of the problems we saw was with the double we're printing out, it just printed out to as many decimal places as it's got, which sometimes looks weird. So we have another print function. Oops, go away. we have another print function called printf. And if you ever take a C programming class, then you'll use this a lot. And the way printf works is inside double quotes, you could print out whatever, just like print line. So you could print out hello there. So this would do the same thing as print. It would just print hello there. But where printf becomes interesting is I could do things like hello, and then there are these special markers, and they all start with the % symbol. So %d is like a placeholder for a integer value. And so, well, what integer is going to go there? Well, after the double quotes, you put a comma and then some number like 10. And then this 10 is going to fill in the slot. And maybe it's a variable, if I put x here. Whatever value is in x is going to fill in the slot. So then it would print out hello, whatever value is stored in x as an integer, and then there. So just to show that real briefly, get rid of these. Here I'm going to put a \n here to make a new line, just because it doesn't do that by default. Int x. So the value of x should be spit out here, which should say hello 12 there. So there's the 12 over here. And then you can do some interesting things, like you could put a number in here that tells you how many spaces wide this field should be. So if you ever want to print out like a table of numbers, and the problem would be like if one number was like 1 digit, but another number was 3 digits, then if you just did print, so they wouldn't line up nicely, they'd have like, some would be 2 extra spaces in them. So this, you could tell it to use like exactly 4 spaces. So if I compile it and run it, then here you can see that the 12 is right justified in like a field of 4 spaces. So there's like 2 blank spaces before the 12. So if I want to print out like an even column of data, then I could specify, this column always takes up 4 spaces or something. And then we can print out floating point numbers. And so let's stick it right here. Here is a float. Here's a double. And to print out a double, you use %f. And let's make a double. And then I'll do comma D. So the order of these things, X and D, is the same order that would appear with the % signs. And so the X comes first, so that would match up right here. And then the D comes second, so that would match up with this %f over here. So if we run this one, then there I get hello 12, here's a double, 3.121, whatever. If you only wanted to print this to a couple of spaces, then there's more formatting here. I can say %1.2. And so this says I have to have at least 1 digit in front of the decimal point, and then only do 2 digits after the decimal point. So there now I just get 3.12. And it will actually round it up for me. So if I make the 3.19, whatever, I should get 3.13. So there's the 3.13. So that's just a tiny bit about using printf. You don't have to use it at all. In fact, most of you will probably just use printline. But if you wanted to, you can use printf, and you have more control over how things are output. And if you want to know more, you can look in the book or look online about printf, and it'll tell you the dozens of different % symbols you can use, and there's a whole bunch of other options in here, like if you want it in scientific notation, and if it is scientific notation, and how many spaces, and all this other stuff. And so there's all these different things you can specify, even though like currency values, so you can specify if something's in dollars or lira or something. Okay, so I think I'll stop talking here and let you work on the drill. So the drill is just a little more practice with variables and some calculations. And then tomorrow's one is essentially the same thing that we did in class, but have you do the scanner on it. So whenever you're ready, let me know and I'll come check you off.